Today I want to talk about this simple circuit. It is the replica of famous 5555 IC, and in a 5555 IC you have a resistor string which divides the voltage by 2 by 3 and 1 by 3, and if you take 5 volts as reference, this node will be at 3.3 volts, this node will be at 1.6 volt. There are these two comparator SI latch and a discharge transistor. This comparator will turn on if the capacitor voltage is less than 1.6 volt, and it will set the latch and the capacitor will start to charge. And when the capacitor reaches 3.3 volts, this comparator will fire and it will reset the latch and the capacitor will start to decrease. And when the capacitor reaches 1.6 volt or lower than 1.6 volt, this comparator will again fire and set the latch. So I will talk about this circuit. Well, it just uses transistors. You can see the SR latch using these two transistors. The comparators are made using these two transistors and these two transistors, the resistor string and the discharge transistor. So how does it work? Imagine this transistor is turned on, basically, which means this transistor is off, and it means that this transistor is on. So when this transistor is on, the capacitor is discharged. So now the capacitor is at 0 volts, so this transistor can turn on. There can be some current flowing through this resistor, through this 5k resistor, from base to emitter of this transistor to the capacitor. So there will be some current flowing through this transistor from emitter to base, and this transistor will turn on this transistor. And when this transistor turns on, this transistor will turn on, shunting this transistor off. So the capacitor will start to charge through this resistor, through the diode to the capacitor. And when the capacitor reaches 3.9 volts, the emitter is at 3.3 volts, so the base needs to be at 3.9 volt to turn this transistor on. So when the capacitor reaches 3.9 volt, it will turn on the transistor, which is going to turn on this PNP transistor. This PNP transistor will turn on this transistor, so the output of the latch will go low and this transistor can turn off and this one will turn on. So basically this transistor will turn on. Basically these two transistor turns on. So basically this transistor will basically let some current flow through this capacitor, through this resistor to the ground. So that's how the circuit is oscillating. You can make a very nice PWM using the chip or this transistor contraption. Well, there is this resistor which charges the capacitor. You can connect these two diodes here. Pin 7 is the discharge, which is same as this transistor. So basically this is our charging state. So we connect these two diode here, potentiometer, and connect the output of the potentiometer to this capacitor, and we have our PWM. We can also make a VCO. You can remove this diode and remove the potentiometer and connect the capacitor straight to this charging diode here. And how it will work is that this resistor needs to be a low resistance resistor and it will charge the capacitor instantly. And when the capacitor charges to up to 3.3 volts, the pin 7 will turn on and it will basically let flow current through this resistor to pin 7 to the ground. And what will happen is that this transistor will take control of the current, and you can set the current by applying some voltage on the base of it. So if the voltage is higher, the current is higher and the capacitor will discharge faster, but if the current is low, it will take longer time to discharge the capacitor. Here you can see the circuit. Here's the oscilloscope. You can see the duty cycle is a lot less, and you can see that it takes very little time for the capacitor to charge and very long time to discharge it. Now it is taking some time for the capacitor to charge and some time to discharge it. Now it is taking longer time for it to charge and shorter time for it to discharge. So that's how it is working. And of course the breadboard has loose connections. But if I look at the switching signal, it looks quite nice. So let's try to make a VCO. Well, I have connected a very high resistance resistor. You can see the frequency is about 329 hertz or 330 hertz. You can see it takes time for it to charge and very low time for it to discharge. Well, now I've connected a transistor contraption and let's see if it works. Well, it works. What is the frequency? 122 hertz, 400, 600, 800, 1 point some 1.92 kilohertz. The pulses are way too short. It only increases as the current through the potentiometer and the current sink increases. This is the lowest. The pulses are not even visible. 200 something hertz to 4 kilohertz.